So if you are told to find the expected value and you know the mean, you know the sample size or number of trials. For example, the one we just did, the number of trials is 11. The the probability of success is 0.15. Therefore, the expected value is 0.15 multiplied by 11. And if you pull your calculator up, you see that the expected value of the mean, 11 multiplied by 0.15, is equal to 1.65, the expected value. The mean is allowed to be decimal. The mean is allowed to be decimal. Okay, so this is the expected value, or expectation for binomial. The expectation is also the same for discrete probability distribution. Okay, so we're going to get one question on discrete probability distribution and make sure we review that today also. Okay, so for the question number 3, it says in the probability distribution to the right, the random variable x represents the number of baseball players obtaining a game over the course of a season. Complete parts A to F. Okay. Okay, so the first thing I want to do is you are given a probability distribution. You haven't verified that it's a probability distribution unless you add all the probabilities and make sure they are equal to 1. So the most important thing to do now is add all the probabilities and make sure that they're equal to 1. Take your time so you don't make any mistake. So I am going to add all the probabilities. So the first one is 0.1677 plus 0.3366 plus 0.2833 plus 0.1488 plus 0.0382 plus 0.0254. Okay, and I'm going to add all of them, which means I'm going to hit enter. Okay, all the probabilities are equal to 1, so it satisfies the 1 probability rule. Now let's see if it satisfies the other one. There is no negative probability, because the laws of probability says that in any probability distribution, the sum of all the probabilities must be equal to 1. And the probability of an event must be between 0 and 1. In other words, there should be no negative probability, and no probability can be greater than 1. So the two conditions are satisfied. Therefore, this distribution is a probability distribution, because that's the question. The question says verify this as a discrete probability distribution. So we can answer the question now. This is a discrete probability distribution because there is no negative probability, and the probability is between 0 and 1 inclusive. Okay. Draw a graph of the probability distribution. Describe the shape of the distribution. Okay, so we can draw the graph of the distribution. So let's go ahead and draw the graph of the distribution. So we can draw it in my, I can round up to 1 decimal point and graph it. But let me see if I can graph it using what I have here. I can make it up from what I have here. So I can minimize. Let me minimize that and see. Okay. All right. So 0 is mapped to 0.2 approximately. 0 is mapped to 0.2. 0 is mapped to 0.2 approximately. 0.2. 1 is mapped to 0.3 approximately. 2 is mapped to 0.3 again, approximately. 3 is mapped to 0.1. 4 is mapped to, I would say, if I round that up, it's going to be approximately 0. Well, let's make it 0.04. 0.04. And 5 is mapped to 0.03. 0.03. Okay, so I am going to check. I'm going to check the first one. The probabilities are on y-axis, and the random variables are on x-axis. So I can see that I can use only 2. 4 is mapped to 0.0304. 5 is, so it cannot be this one, because 4 and 5 are the smallest. So actually you can eliminate here. You can actually see that this is because it's not this. This is not this one. It is probably not this one too. Okay, so so it is B. Okay. All right. The next one is find the mean, and find the question. The next question says compute and interpret the mean and of the random variables. So find the mean and find the standard deviation. They'll ask you to find the mean and find the standard deviation. So what you want to do is put it in your L1 and L2. And by the way, I'm looking at that data now. It's skewed right, because it's asking you whether the data is skewed right. Yes, data is skewed right by my looking at a graph. That data is skewed right. What is the probability that in a randomly selected game, the player got more than one hit? So the probability that a player got more than one hit is adding all these, adding the probability of 2 to probability of 5. So if the player got more than one hit, it says more than, so 1 is not included. Therefore, the random variables are 2, 3, 4, 5. You add all these 2, 3, 4, 5. Now, the next thing is find the mean and standard deviation of a discrete random variable. Anytime you're told to find the mean and standard deviation of a discrete random variable, you pull out your calculator and put the data in L1 and L2, where the random variable is in L1 and the probability is in L2. So let me just do that. So I'm going to go to Start, Edit, and clear L2, clear L1, and then clear L2 and L1, and then put in all the random variables in L1. So 0 and 1, and the random variables must be discrete. They cannot be decimals. 2, 3, 4, 5. And then the probabilities are in L2. So I got to type the 4 digits that I have, okay, in 4 decimal places, 0.1677, enter, 0.3366, enter, 0.2833, enter, 0.2833, enter, 0.1488, enter, 0.0382, enter, 0.0254. When I hit enter, I have typed in all the probabilities to 4 decimal places. Now I want to find the mean and standard deviation. All you have to do is do one variable start to find the mean and standard deviation. So I'm going to go to STAT, edit. And by the way, I just edited. Okay, I'm going to calculate. So go to STAT, arrow to calc, do one variable start of L1 and L2 because you have probability. You have probability, so it's like a group data. So find the mean and standard deviation by doing one variable start of L1 and L2. And when you calculate, you have that the mean of that data is 1.63 approximately. The mean is 1.63 and the standard deviation is 1.83. You could also be told to find the variance. The variance is the square of standard deviation. So if you're told to find the variance, you square the standard deviation. And that's it, actually. That is about, that's the most important things you need to know in review of discrete distribution. First of all, make sure they obey the rules. The 2 important rules of probability must be obeyed. And then find each probability. If you're asked to find the probability, if you're told to find the mean and the standard deviation, you can do NP if you're looking for one, but actually you are looking for the mean and standard deviation. I know that's a formula. It's easier for you to use your calculator. So what you want to do is do one variable start and use the mean, find the mean and standard deviation. So it is easier to use the mean and standard deviation with a calculator. So I hope you don't have any question. Suppose you want to use calculator, but I mean, suppose you decide to use formula. Let me just pull up the, let me see where we have the formula sheet. And then I'm going to get the mean and formula, the formula for mean and standard deviation of a discrete random variable. You don't really want to do it that way. So for number, we're talking about chapter 6. So discrete probability distribution. So anytime you are told to find the mean, you could use this formula if you don't want to use your calculator. But if you use your calculator, it's easier for you. So the expected total of the expected, okay, so draw a diagram for sampling distribution. Let's draw a normal distribution. Remember that this normal distribution is made up of x bars. So the random variable is x bars. We already know this. And the mean of this mean distribution is mu x bar. And the mu x bar is equal to the mean of the original data. So this mean is 85. The standard error of this data is equal to the standard deviation of the original data divided by square root of sample size. sample size is 64. So square root of sample size, I'm just going to write sample size here. Okay, so when I substitute the standard deviation, I'll have 8 divided by square root of 64. Square root of 64 is 8 also. Therefore, mu x bar is equal to 1. Mu x bar is equal to 1. So mu x bar is 1. The mean of the mean distribution is 85. So that is as an easy question. Okay, let's go to number 26. Question number 26. Suppose a simple random sample of size n equal to 15 is obtained from a population with mean of mu x by 64. Mu x by 64. So mu x bar is 64, and the standard deviation of the original data is 19. So for this number 26, I am going to clear all the things written above. Okay, so, and actually I can use my whiteboard. So now I'm going to use my whiteboard. So all the things given to me is that the mean of the data, the sample size of the data is n equal to 15. The mean of the data number 64, 26 is 64, and the standard deviation is 19. So the mean of the original data is 64, and the standard deviation of the original data is 19. Okay, and that's what we are given. Okay, that's what we were given. So the question is, what must be true regarding the distribution of the population in order to use the normal model to compute the probabilities regarding the sample mean? Assuming the normal model can be used, describe the sampling distribution. So describe the sampling distribution. For me to describe the sampling distribution, all I need to do is find the mu x bar. The mu x bar is equal to the mean of the original data. The standard error is equal to the standard deviation of the original data divided by square root of sample size. Okay. And the data must be normally distributed. It is from a simple random sample. So I have described it for A. B, so let's go to question B. So assuming the normal model can be used, determine the probability of x bar, the random variable x bar is 67.2. So I'm going to draw a normal curve. So draw a normal curve. The mean of this data, mu x bar, is 64. They want me to establish the area under the sampling distribution from x bar less than 67.2. So that point must be at the right hand side of the mean, 67.2 percentile. So they want me to find the area to the left of 67.2. I already know that the negative infinity will be 1 e to the power 99. All right, so I am going to write the argument that I will give my calculator. So I'll tell my calculator that I'm looking for the area to the left of 62.7. All these are raw data, but you already know that my calculator can calculate area under standard normal curve. My calculator can calculate area under standard normal curve. So mu normal CDF. So I'm going to write the argument normal CDF starting from the lower bound, which is negative infinity 1e to power 99, and to the upper bound, which is 67.2, 67.2. The mean of the central limit theorem is 64. And the standard deviation of the central limit theorem, which is standard error, is 19 over square root of 15. 19 over square root of 15. Okay. Now I get my calculator and put all this in and find the area inside the normal curve. Because that area is area to the left, it's also called percentile. Area to the left in a normal curve is called percentile. So I'm going to fit that into my calculator. So I'm going to turn normal CDF on in my calculator. Second distribution, normal CDF. The lower bound is negative infinity. It's already here. I don't have to put it in again. Even though that this data is not standardized, I can still use it. My calculator is intelligent. It knows how to calculate area under the normal curve, even without standardizing it. So upper bound is 67.2. The mean of this data, the raw data, is 64. The mean of the sampling distribution is 64. And the standard error is 19 over square root of 15. 19 divided by square root of 15. Square root of 15. And I'm going to put 15 here. When I close parentheses and I hit enter, my answer is 0.74, approximately 743 to 3 decimal places. So the area to the left is 0.743. So that is 74.3%. And this can also be called percentile. So it is 0.743 percentile. So the area to the left of 67.2 of that data is 64.3 or 0.743. So we have answered this question. The question in, let's look at that question again. So that question says, B, since the sample size is large enough, the population, okay, that's B, A. Assuming the normal model can be used, determine. So I just found the area to the left of 67.2. So the next question is C. Assuming the normal model can be used, determine area to the right. So I'm going to do area to the right. So this is another question, area to the right of 66.4. So let's find area to the right of 66.4. So I am going to, everything is going to be the same except area to the right of 66.4. So I'm going to draw a normal curve and show the area from 66.4 So note that we are looking for area to the right. Find the probability. I hope you know that this is probability. Probability. Find the probability that the random variable is greater than or equal to. So you're looking for area to the right this time. So area to the right is not percentile. This is not percentile. So the first thing to do is to draw a normal curve and show 66.4. 66.4 is greater than the mean. The mean is right here, and the mean is 64. So 66.4. Here, approximately area to the right. That's area to the right. Okay, and so area to the right is from 66.4 to positive infinity. So let me write the argument I would use, tell my calculator. That argument is normal cumulative density function. The lower bound is 66.4. The upper bound is 1e to the power 99. The mean is 64. The standard error is 19 over square root of 15. 19 divided by square root of 15. Okay, so now that I have written the argument, I will put in my calculator. I will pull my calculator up and find area to the right. So let's find area to the right of 64.4, 66.4. So I'm going to clear and go back to second distribution, number 2. Okay, so the lower bound is 66.4. The upper bound is positive infinity, 1 e to the power 99. E is above common, don't forget. 1 e to the power 99. The mean of the standard of the sampling distribution is 64, and the standard error is 19 divided by square root of 15. So now I'm going to calculate, and I'm calculating area to the right. I'm calculating area to the right of 64.5. All right, so now I'll hit enter, and my calculator is asking me, is that the argument you want? Yes, that is the argument that I want. Therefore, area to the right is 31.23. Area to the right is 31.23%. So 31.23%. I can write it in decimal. This area to the right. So the area to the right of 66.4 is 31.23. Okay, I hope this is clear. So this is still about sampling distribution, but we're doing a review today since our test is on Friday. So if you do have any question, let me know. So we have solved many problems on central limit theorem or sampling distribution, or you can call it sampling distribution also. Okay. Okay. So the next thing now is we have already answered question number 26. So we have reviewed sampling distribution.